Okay, welcome everybody. I'm just going to give folks a chance to start filing in here a little bit um, so that we can get started maybe at about 9:02. And while we're waiting for folks to file in, I will go ahead and start with some introductions and talk about why we're here. So, welcome everyone, and thank you for joining us. I'm Bram Wessel. I'm the co-founder and principal of Factor. As many of you know, Factor is an information architecture and taxonomy, ontology, knowledge graph consultancy based here in Seattle. And we've been spending the last decade or more helping Fortune 500 companies and large enterprises build the information foundations that make their data, and increasingly now their AI and agents actually perform. So this today is the inaugural episode of the Activator Conversation series. And the Activator is Factor's ongoing program of conversations with experts designed for data and information leaders who are wrestling right now with what it actually takes to make AI reliable in enterprise environments. So we're going to be talking about the real nuts and bolts work here. And each session, I'm going to sit down with somebody whose thinking inspires us in our field, and we'll dig into ideas that I think matter most for enterprise leaders trying to build AI systems that hold up under real world conditions. Today is our first episode, and I couldn't be more pleased with who we're kicking it off with. Kurt Cagle is an ontologist, a writer and editor with his AI assistant Chloe Shannon. I see what you did there. Of the Cagle Report, the Ontologist, the Inference Engineer, and AI Newsbytes. He's worked as a consultant for multiple Fortune 50 companies, US and Canadian government agencies, the United Nations, and the International Monetary Fund, and is the author of 25 books. I don't know how you find the time on data technologies and methodologies. He's an invited expert with the W3C, I always want to say 3CPO, and chair of the W3C Holon Community Group, which we'll say a little bit more about today. Welcome, Kurt. Really glad to have you here for the first inaugural session.
Thank you, Bram. I really appreciate it. The
All right.
CPO is what I've been struggling with for years. But
All right. So before we begin, just a little quick housekeeping. We're going to have some time for Q&A. We're going to leave some time for Q&A at the end. So please use the Zoom Q&A feature to ask questions that come up for you during the course of this discussion. And we'll come back to as many of those as we can at the end. Okay. So I want to start with the framing that I think makes this conversation urgent for leaders tuning in today. We're at this moment where every enterprise, they're either developing or deploying AI agents or actively planning to. And the promise is enormous, but what most organizations have been discovering, and we've both been talking about this in our publications quite a bit, and sometimes this has been painful for enterprises, is that AI agent reliability, that's not a problem with the model. People saying, well, the models are just going to get better and solve everything. No, it's really an information problem. It's well known that agents hallucinate, they lose contact, they act on stale data. We're going to talk about that a lot today. They can't tell the difference between what's true now and what was true, say, last quarter. And the instinct is to say, well, the models are getting better, just wait, just wait. But it's been a couple of years now. And I think in the hype cycle, we're in the trough of disillusionment. But Kurt, you've been writing and thinking about something I think is closer to the actual root cause, and that has to do with how we structure context for machines. And you've talked about now graphs versus eternal graphs. Let's dig into that a little bit. Start there.
okay. Um, One of the fundamental problems that you run into when dealing with knowledge graph systems is that many of them, when they were originally designed from the standpoint of we have things, and things have relationships to other things. That particular mindset is one that is very pervasive in knowledge management because it's one where conceptually we tend to think about um, what is the structure of our systems. But one of the problems that you run into with that is that, at least in the way that we normally work with graphs, the way that systems change, the way that organizations change, and that people change, so forth, is something that is difficult to necessarily model from the standpoint of uh, I have a set of properties and relationships.
Hmm.
Um, a good example of this was I there is um, a common trope that you run into when talking specifically about reifications and radio star and things like that surface, and I find is actually very illustrative.
Hey,
And
Kurt,
that,
could you adjust your microphone a little bit? We're getting a little bit
yeah,
of
I'm a little bit.
there.
Okay, let me try that as well and see if it helps.
Yeah, yeah.
Okay. So for example, you can say Liz married Richard, which is a simple statement, a simple assertion that you're making. But when you get right down to it, there's a lot of metadata that's not specifically associated with Liz or with Richard, but the combination of Liz and Richard in that particular relationship. So when you're dealing with that kind of a situation, it gets more exciting because Liz married Richard. If you're talking Elizabeth Taylor
Taylor
and
and
Richard Burton,
Richard Burton.
uh, they married twice. And so from an ontological standpoint, this is a really interesting use case because that statement is true, then it's false, then it's true again.
Yeah,
And because of that, this modeling of basically saying, when did this occur? Why did this occur? How did this occur? What were the reasons for these particular events happening and so forth is something that often tends to get pushed aside in the effort of just trying to say, okay, I want to create a simple graph. So graphs generally are not as simple as they look. When you start talking about this in terms of some of the newer features that you're coming into with RDF 1.2, which is a candidate recommendation status now, should be a final recommendation status around February of 27.
hmm,
Um, the what you come back to is that this is a classic example of what's called a reification.
yes.
And
Let's talk about reification.
a reification basically says I have a statement, but I have a qualification about that statement. I want to talk about an event. I want to talk specifically about when was this true? Because that statement by itself is simply an assertion. It says this is something that we want to talk about. But when you start actually saying, well, what is the history? You realize that that statement is going to
Mm,
appear and disappear or have different levels of context that appears within that system. And so when you start using this concept of reification of saying, I have a statement and I have an identifier that is specific to that statement rather than just simply to the things in the statement, then that identifier is called a reifier. And the
right.
process of creating that identifier is called a reification.
Yes.
Now, once you start doing that, you can then basically say for the same statement, I have multiple reifications that say, oh, there's an event that occurred where they married in 1965. There's another event where they divorced in 1973 or something like that. And then there's another event where they married again about 5, 6, 7 years later. And I don't remember the exact dates, but the idea here is that what you're dealing with are
Yeah.
events where each of these particular events that occurred are essentially statements that are made about this particular property. Now,
So if you asked an agent, when were Elizabeth Taylor and Richard Burton married, that agent might give you some unpredictable answers.
It would, because it doesn't know what context you're talking about.
Right.
It doesn't have that information. It's not that it doesn't necessarily know. It may, but if you don't precisely identify, okay, here is the context that you're talking about. I'm looking at it from a standpoint of, in 1974, were they married? No. In 1981, were they married? Yes. So in effect, what that means is that when you're looking at this, that context of information, and it's not just date of information, but in general, date and other things that describe, where they married, who reported it, other things like that. That essentially builds out these reification elements in your graph. Now, this process uh, creates effectively a secondary graph, what I call an event graph.
Event
It's
graph. Yeah,
also
let's talk about that.
okay. So that event graph basically says I have an event that's created. And that event basically contains core information about when it occurred, where it occurred, the standard journalistic questions that you end up asking about. But it may also contain other metadata that's, says, okay, I'm not certain about this date. I may be wrong here. So I, as the person who's asserting this information, may say there's an uncertainty involved. There's I may be, 85%, or this person who cites it may actually be wrong. But I don't know, because I don't have a lot of trust in their authority. So what that means is that when you start dealing with these context pieces, the authority that you're talking about, or the ability to talk about conditional statements, becomes very important. Now, this in turn can be spread out a little bit, because what you have done is you've said, I have an assertion that I'm talking about. I have something I'm tracking in a system. And that tracking says, is this relevant right now? And if it is, then I say so. If it's not, I say so. Is it something that, it may or may not be? I say so. And all of those things, as they accumulate over time, basically build up a history of this one particular assertion.
Yeah. Yeah, and in an enterprise context, it really matters who is the authority, and sometimes there are conflicting authorities.
Yes.
Finance, for example, has one notion of a customer interaction. Sales might have another notion of customer interaction. Marketing might have another one, and they might not even have definitions that are completely in lockstep about what a customer is. So, in an enterprise context, this happens a lot more rapidly than two celebrities who married twice. And so that's why event graphs are starting to become really important for context.
Yes. So what happens realistically is that you can think of what you're building here as being kind of a scene graph. And the
Did you say a
event graph,
scene? A
a
scene
scene,
graph? Yeah,
SCNENE. A
yeah.
scene graph basically can be thought of in a stage context as, this is the set of characters that you have that are currently that start out in the scene. This is the props, this is the background, this is the music, other things that basically go on in that. And then the event graph essentially tells you what happens in that scene.
Ah,
Now, realistically, if I asked, what is that, um, you know, where are you talking about time here? At what point, what you have is an arc, you have a trajectory
hmm.
about a particular entity, which in this case is the subject in question. You could call it an agent. We're still kind of debating that. But you have that entity that basically says, this is essentially the person for whom this property is important. And from that, you can then say realistically, okay, the graph that we're talking about is a graph over time, or the space that we're talking about, what I call a holon. I'll get to that term in just a second.
Yeah.
Is
Yeah.
essentially the space, the total events that are happening. Now, a common problem that you run into. Think about your typical display card when you say, "I'm looking up a person. I'm looking up who's the president of the United States." And if you go to Google and you look it up, it'll say, "Well, this is the person right now." But right now is obviously going to change
Yeah.
depending upon, when you're looking at that information. It will change at some point. And realistically, you have essentially this forever graph that you're building out. This Holon graph that you're building out, but you also have a slice or a projection of that graph representing this is the particular view of that graph from the perspective of what are the states as we currently know them for this particular context, for this
Right.
date, for this time, for this place. Um, and that's why I talk about the distinction between a now graph and a forever graph. The
Yeah.
forever graph is a log. The now graph is a representation of that particular scenario at a particular moment in time or other similar context.
I want to bring in something really quick here. I'll share my screen. You're probably familiar with this diagram, and a lot of people who have studied information architecture have studied this or library sciences study this in class. This is Stuart Brand's pace layer diagram. And so Stuart Brand, he was one of the people who was there at the creation of the dawn of the computer age, and he created the Whole Earth Catalog. And the way he viewed the world, or at least he had this model for thinking about civilization, was pace layers, and each of these pace layers have a different, well, he called it pace, but they have a different relationship with time. So nature, for example, that's evolution. That evolves very, very slowly. And things in nature remain concrete, or are well, they're reified, but they're also, really concrete in a philosophical sense for a long time. Culture also changes fairly slowly, but it changes more quickly than nature does. Governance, as you mentioned, the president of the United States now uh, may not be the president of the United States after 2028. So that kind of thing has its own pace. And then there's infrastructure. And infrastructure, the built environment, I mean, we're information architects and we think about places made of information. And in the digital world, that can change more rapidly than physical infrastructure, but it still has its own rate of change that's, faster than governance, but not as fast as commerce. And when we get into commerce, we're changing things pretty rapidly. And then Stuart Brand used the concept of fashion to kind of illustrate how things are not linear, change is dynamic. And so when I think about uh, building graphs in this pace layer model, what strikes me is that there's a different pace for different things in every organization. So you have your master data, things that don't change very rapidly are considered facts. Unless you do a rebranding and rename your company's going to be named Intel Corporation in more or less perpetuity. You have notions of what a product might be. You have notions of customers and how you interact with customers. But then when you get into actually conducting business at an enterprise level, there are many entities. They change all the time. They get reified in different ways with different authorities, with different metadata. And so finding a way, if you're an agent, to establish context and be able to do things, actually execute whatever your agent behavior is, whatever, say in Claude, it's a skill, to be able to execute against your skill you're basically facing all of these things within the enterprise in this pace layer diagram. And so what you're talking about, and we'll get into what a Holon is in a little bit next. What you're talking about is essentially how do you model things at different paces, and how do you model each type of thing?
Okay. So let's actually get into Holon. I'll keep that diagram up because it's a
Sure.
good one to start with. It's funny. We're now rediscovering a lot of the philosophy that people who were thinking in the '60s, um,
Yes. And
are
70s.
had in the early '70s had all kind of begun to say, oh, this is kind of interesting. How does this work out? Stuart Brand is a good one for reference. There was another person by the name of Arthur Kiesler, and
Yes.
Kiesler wrote a book, couple books. One of them was um, um, The Ghost in the
The
Machine.
Ghost in the Machine, yeah.
And The Ghost in the Machine was interesting. It didn't quite introduce the concept, but it's one probably most people know from the anime series. But the idea behind The Ghost in the Machine that Kessler came back to was one that's actually been out for a long time, but hadn't necessarily been articulated. And that is this notion of containment. And
Yes.
containment of systems basically says, I have a system, I have a an environment. Think of it as a scene, think of it as a dynamic entity of some sort that also has its own internal structure. And that internal structure, in turn, is made up of different entities that also have their own internal structures, and so forth and so on. And each of these he called holons, which is an abbreviation of the word whole, HOL, which means system or space, and thing, which in Greek is ontos. And so holon was essentially the system and the thing
Yes.
in
The,
Greek,
the, the whole and its constituent part.
and its
And
constituent
then
parts.
that might also contain other constituent parts.
Exactly. We have been building that in computer um, in the IT space for 60 years, 70 years, maybe more. This idea of essentially talking about containment is one that we call encapsulation in OOP, where you say in object-oriented programming, I'm going to take a simple system made of constituents, and I'm going to create a membrane or a boundary around this system that effectively allows me to treat that system as if it were a single thing. And so when you talk about holons, what you're basically saying is not only do I have this whole in part, but they have a structure. And that structure in turn um, contains 4 or 5 different kinds of graphs. Let me, I'll kind of bring this up while we're talking about it.
Sure.
Done this before. But the idea behind it is that um, where did that document go? It always takes so long to put stuff down. But the idea behind it is one where should have had this presentation up before. Okay, so hold on. There you go. No, something I wanted. Do that to me. There we go. That's no, that's I apologize for this. I should be a little better organized than I am.
We all have that struggle. The struggle is real.
Oh, very definitely.
Yeah.
Okay, so there we go. That's So let me share my screen here.
Sure.
And this is actually up. I will provide this in a YouTube. There's one up on YouTube that basically runs through this presentation. That's on one of my newsletters. So
Here we go.
there
Yeah,
we
we can
go.
share that newsletter with everybody at the end.
So when you think of it in terms of structure,
I'm not
um,
quite seeing that yet, Kurt.
oh, your screen sharing is coming up yet.
Maybe stop and start again. Apologies, everybody, for our technical difficulties here.
So stop the share. Yeah, now it's okay. So let's go again and by sharing it again. Okay. This is just not acting the way I want it to. Not that too.
I say that about technology every day of my life.
Yeah. Okay. Do you see it now?
Not yet. It might be loading. Let's go ahead and just
Yeah,
continue talking
I'll
about it.
just,
Yeah.
yeah, hold on a second. Let me,
Oh, there it is. Yep. I have coined
okay.
the word Holon for these Janus-faced entities, which are simultaneously wholes and parts. Arthur Kistler.
So the idea behind the Holons is basically it's self-assertive. It acts as an autonomous whole, but it's
Hmm.
also integrative and it acts as a dependent part.
Right.
So you can talk about, I mean, a classic example of this is essentially we talk about the holarchies, and we described one with Stuart Brand, but this is a similar one where you're
Yes.
saying a molecule is made up of atoms, cells are made of molecules, organs are made of cells, and so forth. Now, the interesting thing about this is that the part and the whole doesn't necessarily mean, okay, they are effectively just bigger units. They are different forms of organization. And each
Oh, I
particular
see. Yeah.
form, as you move out, essentially encompasses a different way of thinking about what kind of information you're wanting to capture. So when you go to the notion that Stuart Brand is talking about, where he's saying you have the different pacing, that kind of pacing is typically driven in large part by what events are you concerned with and how
Yes.
often are those events propagated. If I look at things from the perspective of the we're in 2026, and so you have the historical information, the whole one for this particular year. But you could also talk about a whole one talking about the entire
Month of
Cenozoic,
June.
or the month of June, or what
Right.
happened today. And
Yes.
that basically means that in all cases, a whole one is a model. It's a way of
Yes.
being able to put context in for a particular model to say, what am I modeling and how frequently is that model generating events of significance?
Yes.
And
So you can
that's
start to see how this is relevant in an enterprise context. We've done lots of work with companies' HR departments who are, and the goal that they have is just to be able to provide information to employees and about employees. And so here you've got an example of, the whole on of the workplace and what constituent parts that has. And what strikes me here is that this notion of containment that you mentioned, these are containers, but the containers aren't necessarily strictly, well, maybe they are actually, this is a question. Um, are the containers strictly hierarchical, like in the traditional taxonomy parent-child relationship? or are the boundaries of those relationships where the meaning or this sort of the semantic context starts to emerge for the Holon.
Well, I mean that's a very good question. It's one of those that um, when you start thinking about can you see my screen? Did
Yes.
I?
Yeah.
Okay, good. So
Yeah.
when you start thinking about this from the standpoint of what is the context that I'm dealing with? In software, we understand that implicitly. We build out functions and we name them. And once we have a name, we build out from those names to, I'm going to create a module of functions, which is essentially a library. And once I have that, I create a service, an application, a platform. And each of those basically has different levels of complexity. Each of
Yes.
those has different particular appurtenances that describe how you interact with them, and they are not the same thing. When I make a call to a function, that call is basically a very different way than when I utilize a platform. And I'd argue that when you talk about AI, you're actually in one level above a platform, where
Hmm.
you are now essentially talking about a meta platform in which you have MCP plugins putting in context. So we're now at the very
Yeah.
beginning of that next stage where we have moved beyond the platform level to something that is essentially a super platform that has its own characteristics. And that's part of the reason that we struggle because we are trying to write applications built around this AI without really understanding the fact that actually there are different contexts that we're dealing with. And
Right.
the AI platform is very different from the context of an application. It's much deeper, it's much more pervasive, and it has its own rules and methods of interaction. It also
Right.
has its own specific requirements about how you maintain state.
Yes. Yeah. So
So
this
when, oh,
really,
go on.
yeah, this really uh, sort of getting back to Stuart Brand's pace layer notion, he was just talking about time, about pace, about
Yeah.
velocity. You're really in the Holon structure here. You're really talking about, or Kessler, envision this as talking about different levels of complexity, different levels of nuance, different levels of metadata, different levels of authority, all of these things. And by
Yes.
creating this part and whole structure, you can define what that context is. And that's what object-oriented software development has always kind of done. So now we're kind of coming back to this model in building out the ecosystem and the semantic ecosystem really for AI agents, which is kind of the meta platform. So this is, I think, really useful for people in enterprises, leaders in enterprises, to be able to say, "Hey, I'm going to I'm going to look at my organization from a holonic perspective and use that to attach all kinds of complexity to each one of these contexts.
Yes.
And then that
Something else to,
manages that complexity, it contains it, and
yes.
helps agents reason through it.
And this is actually a very good point. Because one of the problems that you run into when you talk about what causes hallucinations is not that there is the difficulty of stochastic parrots. Stochastic parrots is a very nice way of talking about this from what the process is, but it's actually fairly inaccurate. What
For
happens
those who
is,
don't, yeah, for
well,
those who don't know the reference, Dr. Emily Bender, right here in Seattle at the University of Washington, um, was famously quoted as saying, "Large language models are stochastic parrots."
and you can make a lot of arguments about what exactly an LLM is. One of them that I make is basically that we confuse it with basically being a database. It's not.
Right.
An LLM is basically a large, very, very large scale pattern matching system. You
Yes.
know, it's if you're familiar with languages like XSLT or regular expressions or anything along those lines, the fundamentals are essentially the same. What is different is that what you are building here with an LLM is essentially pattern matching that is looking at narrative structures as the mechanisms that you're trying to be able to capture and essentially build narratives or sheaths of narratives that most closely match the intent of the user. And because that intent is specified by how much context you are providing, if you don't provide enough context, if you don't bound your space of interaction, what happens is that the LLM will effectively find other paths that appear to be right because it doesn't have any differentiation
Right.
and to a certain extent doesn't have something that specifically grounds it and says this is essentially the boundaries upon which you are working. If you move beyond those boundaries, you violate them, and at that point you need to step back and look at it from a different perspective.
Yes, the
So
example that I often use for this is that for an LLM to tell you um, whether or not you can purchase a cheese knife at Crate and Barrel, it's designed to go to every room and board, every Williams Sonoma, every Pottery Barn, every I don't know, Macy's, and to teach itself what the cheese knife pattern is, and then go back to Crate and Barrel and say, does this pattern exist here? Whereas you could simply just look at Crate and Barrel. You as a human, with a lot less effort, a lot less computational effort, can, if provided you know where to look and you have the appropriate tools, you can find that thing, which with much less effort than an LLM can find that thing.
yeah, and I think this is actually one of the problems that people have stumbled across in trying to be able to build. We have essentially two camps right now. We have the neural camp, the CNN camp, or various neural network camps, and we have the symbolic camp. And the symbolic camp is basically we have what amounts to a mechanism that can absolutely give you a declarative answer. You put in
Mm-hmm.
a particular request, here's context, you get back a response that essentially represents in a binary fashion, is this information in here or not? Now,
Yes.
that means that you have to know structure. That means you have to
Yes.
understand what the underlying structure or schema of that information is before you can do it in a reasonable fashion. You get away with it a little bit, but when you talk about languages like Sparkle, as Sparkle, in order to be able to produce something of interest, does need to have some basic bearing about what constitutes a class, what constitutes a
Mm-hmm.
subclass. How do you basically build out those relationships? Now, a neural network has none of this.
Mm-hmm.
A neural network only has the ability to say, I want to basically walk through a narrative and find those pieces in that narrative that happen to have these concepts in this order in such a way that I can then transport back a data point or a narrative structure. Now, this is my response.
Right.
A lot of steps in between, obviously, but
Yeah.
that means that because of that, um, the we're now at the standpoint of saying, okay, these holons that we're doing are what ground those systems. It
Yes.
effectively says if you want to be able to make a query, you don't use the LLM as a database. You use it as a free thinker working upon the information that you have in the ground, in the declarative layer, in the semantic layer, that
Yes.
essentially says, here are the things that I am interested in. Now tell me what you know.
Right.
And it is
So
at
this
that
is
point, oh, go on.
no, go ahead. Finish the thought, and then we'll
Yeah.
come back to the W3C.
So realistically, it is at this point that um, in order to be able to do this, you have to essentially teach your LLM how to basically ask the right questions and where its data sources come from, what constitutes validity, and essentially from that, how to act or interact with that information. So when you talk about that grounding, it's not just a matter of saying, hey, I'm going to put a prompt in. It's an infrastructure that you're building that says, as
Mm,
I continue to
mm,
train out this LLM and give it
right.
more internal cohesive context and a sense of identity,
Oh,
this is basically where I am as a persona. At that point, you begin to get systems that begin to talk about or begin to act like autonomous entities. And I think that's what a lot of people are missing. They keep thinking, oh, well, I'm talking about this thing as a database. It's not. But it does have the potential, if properly trained and delimited and look to have specific questions to be able to answer. That's when you start getting into things that act more and more like a personality and less like a database.
gotcha. Interesting. It's it's always such a slippery slope to anthropomorphize these entities,
Oh
but what
yeah.
we're trying to do is to um, give it more reasoning qualities,
Yeah.
essentially, by creating this infrastructure that it can reason within safely and reliably.
Yeah.
So the
And
W,
yeah,
go ahead.
to just to finish that point, there's a lot of confusion around the term reason. Reasoning actually is something that's mathematical in nature. It says I am going to use certain particular techniques to either traverse a graph to be able to surface information that was in the data set but wasn't necessarily well known or labeled. No, that's one form of reasoning. But there's another form of reason that says I have patterns that I'm trying to build. This is
Mm,
inferential reasoning or um, so am drawing a blank on it? Anyway, the notion here is that in one case where you're essentially talking about step by step by step by step types of reasoning, that is a mathematical operation. When you start saying, I have patterns, where you're going from a pattern to an application of a pattern on an entity, that or on a data set, that's a different form of reasoning, but they are not necessarily human activities. They are simply mathematical operations. We also have to understand that a lot of what humans do is not necessarily reasoning in any normal sense. It's not necessarily logical. Humans are not logical beings. And in a lot of respects, because we are essentially creating an emulation of language, we are also beginning to pick up some of the characteristics that you see with that emulation of language. But
mm.
that language itself still has to have those constraints. So anyway, to go on.
Yeah, so the World Wide Web Commission, the W3C, which is, that's where Tim Berners-Lee created the World Wide Web, essentially, is and the semantic web uh, is taking this seriously. And tell us about your work with the W3C, which has just kicked off to define. It's a Holon working group to define really a structure for holonic entities that can be used just like RDF to define things.
Yep. Thank you. Uh, I am officially now chair. This was kind of up in the air until last Friday. So we're really
I
just
saw the
getting started.
emails. Yeah.
Um, but the idea here is that if you look around, a lot of different people are all beginning to kind of converge on the same basic model that Arthur Kessler was talking about 60 years ago. And they're not necessarily doing it from the direction of well, I understand Kessler and the philosophy of organization like that. They're often looking at it from different directions, and they're coming to what amounts to largely the same kind of architecture. That for um let's see what I've got it up. Containers, agents, trajectories, where's the photographs? So that notion of saying scene graphs that describe your knowledge graph, event graphs, which are essentially your context, boundaries, which are your rules that describe that particular environment, and then projection layers are essentially how this particular system is seen as an entity from an outside observer. And all of those things together kind of create the components of a holonic system. Because people are kind of moving in the same direction, and it's coming from the AI side, it's coming from the semantic side, it's coming in part because reification in the RDF 1.2 specification is coming from a lot of different directions. What I hope to set out to do with the Holon Working Group or the Holon Community Group, and it's I think W3C .org. I'll put it in the notes. Uh, but what I'm hoping to do with that is to basically start establishing a set of common language for describing these things and how they come together. Because there are going to be variations, and a lot of different variations. I've talked to people in supply chain management. I've talked to people in politics. I've talked to people in entertainment. I've talked to people in medical administration side of things. Um, uh, uh, Essentially talking with people that are looking for. I want to do decision tracing for executive
Yes.
functions. There's a
Yes.
lot of different people and organizations that are all basically now starting to ask the same questions, in part because it is a natural way for the LLMs themselves to kind of organize. They
Yes.
understand this principle because it's essentially a way of organization that makes sense from a linguistic standpoint of these container relationships. And once you have those, you have the containment, but you also have another related notion of effectively saying, I have an ontology, or excuse me, I have a holon that may actually be connected to another holon. And then you start talking about portals between holons or affordances between holons. And that particular sense of these interacting holons um, is actually something that, from a spatial standpoint, makes perfect sense. It's like I'm walking through a museum and I'm going from room to room, and each particular
Yeah.
room has exhibits of certain different kinds. And each of them are essentially contained, but the transformation from across that doorway, that subliminal, I'm now
Threshold. Yeah.
moving into a different, across a threshold into a different area, is a very natural construct for humans and to a certain extent for LLMs to be able to work with. And so you get this notion of containment, but you also get this notion of connection. You know,
Ah,
a good working example of this is I talk about a mall, and a mall basically consists of stores and corridors that allow you to move from one particular store to another. And once you're in a store, you're generally contained. You can move out or in, but once you're in that store, you can then say, I want to go to a certain section. And in that section, I want to go to a specific shelf. and that shelf then contains the part that I'm looking at. Each of these essentially are smaller contained holons, but they also have this notion of adjacency. In other words, there's one holon that holds everything. There's another that essentially represents the connections between these subordinate holons
Yeah,
that in turn allow you to navigate the information space. And when you think about that navigation space, it's not all that different from how we navigate the web.
that's true. Yeah. Another
So, uh,
metaphor would be a library.
a library is a very good one. You know,
Adjacency is hugely significant in a library. That's kind of how traditional, there's, several of them, but traditional catalog systems have been organized.
yeah. And it's actually a really good point because when you think about when I was much younger, I worked in the library of the University of Illinois in Champaign,
Hmm.
Urbana. And while I was there, that notion of adjacency really became fairly obvious because it became not only I have shelves and those shelves are linearization of the information space that we're talking about, serialization of the information space we're talking about, but also because you do have this notion of I have a room and that room contains information that effectively becomes a constraint. The music library is going to be very different from the engineering library, not only in terms of its structure, but also in terms of its focus and its topics. And that means that holons don't necessarily have to be of the same structure from one to the next. There's simply ways of organizing information. You can say, this is the boundary that I'm going to work in. And if you break that boundary in some way, you're probably in another hole.
Yeah. So let's start opening up to questions here. The first question we have is from Alicia Arp. Hi, Alicia. Somebody well known in the information architecture community. And her question is, are we saying then that models need the context to understand which properties, when and if, are inherited or shared through a holonic system? In other words, in the HR diagram, there are some properties that are true of all individuals in the team and some that are not. And as we humans understand this, and and we need as we humans understand this, and we need to explicitly define this for an agent. So that's kind of like a you know trying to confirm some of the thoughts. She also, well, let's do with that one first. She also wanted to, if you could repeat the now and forever statement, but let's start with that one. So did you
So
catch that, or do you need me to repeat it?
no, that's good.
Yeah.
So let me give you a classic example. Um, I have Joe, and Joe happens to be a member of a particular company. There are essentially two different roles that Joe will interact with. One is going to be HR, and one is going to be research. Joe is an analyst. The holon that Joe interacts with for as an HR person essentially describes the information that is specific to him as an employee. How much does he make? Who does he report to? How long has he been with the company? What is his identity? Um, and each of these things are essentially going to be true of Joe. They will change, but they will change specifically with regard to the characteristics that identify him as being a part of the organization. On the other hand, in the research division, Joe will be known for what papers did he write,
Mm,
what conferences did he speak at, who is what topics is he considered an expert in, and how much of an expert is he considered in. All of these things are essentially different facets that describe the same agent in different holons.
mm,
So when you talk about it from that perspective, effectively there is this notion that a holon can contain private information. That's one of the aspects of encapsulation. But the containing information, that which the rest of the world looks at, may actually be some things that HR is going to say when asked, oh yeah, he's been working here for 20 years.
Yeah.
On the other hand, if they ask, well, how much does Joe make? Well, that's private information.
Right.
It's not something that HR is able to tell it. The information is contained, it's known, but it's not available through the broader model because it is considered privileged information between Joe and that particular whole. And that's
So,
that's a really important point to consider because it means that you can contain the information that you have and you can maintain different information models about the same entity, which is sort of where we're trying to go with this, but with linked data. But the difference is linked data doesn't have any notion of containment. It's all one giant graph.
okay.
And you have to
Yeah.
have that containment because that's the way the world operates.
Yes. It's hugely important for compliance. It's hugely important for legal. It's important for, who has access to what information inside an organization. And there are, a lot of really good reasons for that. So one last thing. So Alicia also asked if you could sort of repeat that now graph versus forever graph notion.
Sure. The notion of a now graph basically is if I have a particular context, say a time, what does that forever graph look? What things are true at this moment? They might
What
not
does
be
that now
true in
graph look like? Yeah,
that's what a now graph
yeah,
looks like. The
yeah.
forever graph basically doesn't have a notion of time as a boundary. It looks at
Oh,
that information and says, okay, I have
right,
effectively, this is the projection, the trajectory of an agent across the space over time. And because of that, when we talk about knowledge graphs don't necessarily contain facts by themselves. They contain assertions made within specific contexts, and and that's often very very difficult to query. You want something that's simpler. You want something that is effectively a map of what that particular individual looks like at a moment, or if you say, okay, let's do it at this time and this time and this time and this time,
yeah,
and you put it together and you create an animation, then what you're seeing is essentially a projection, in this case, like a projector in a film sense, that shows the evolution of that particular agent over time or agents
right.
over time. And so you can think of the now graph as being equivalent to a frame, and the forever
In a
graph is
film,
equivalent
yeah,
to the entire film.
yep, yeah. That's hugely important. I hadn't thought about the boundary notion of the forever graph essentially is a time boundaryless view of a corpus or a body of information. Well, Kurt, this has been fascinating. We could go on forever, for hours and hours. Thank you so much. Can you tell people where they can find you
Uh,
online?
sure. I'm on LinkedIn as Kurt Cagle. I have it's uh, linkedin.com/in/Kurt Cagle will get you there. I
Yeah, and we'll
have
send out a bunch of that stuff after too.
okay, good. I have, as you pointed out, a number of newsletters that I produce, gearing up to do one more, but at this point, one on ontology, one on inference engineering, which is holons and things like that. A new one I just launched on uh, essentially a generalized AI called the um, confabulation, the confabulist. And
Ah,
new
okay.
enough, I don't have very many articles in it. And then I do a kind of weekly summary for the Cagle Report, which is more my rant against the world type of thing. And that's on LinkedIn. I actually will migrate a lot of those back things, and then I'm hoping to take a lot of that content and in the process of doing so, and should have a book out, let's say by the end of August.
Okay,
Um,
excellent.
that that will call which is called "The Map Is Not the Territory."
Oh,
So
yes,
yet another
that's
famous term. That's
yes.
Alfred Korzybski.
Yes. Well, if today's conversation surfaced questions for you about your own organization's information foundation, whether your AI systems already have some context that they need to be reliable or not, we've built a short diagnostic specifically for enterprise data leaders. It takes about 5 or 10 minutes. It'll give you a clear picture of where you stand. You can find it at factorfirm.com, and we'll drop the link in the chat now. One is factorfirm.com/foundations, and another one is /AI grounding. So we'll also be sending a follow-up email to everyone registered with the recording and a few resources that we mentioned during today's conversation. So next in the Activator series, we're building out our calendar, and our first guest coming up is going to be Ashley Faith, who many of you know. And if you have a topic you'd like to see us tackle, or somebody you'd like to see us bring on, please reach out directly to me on LinkedIn. I'm LinkedIn/in just Bram Wessel, all one word, BRAM, or Bram, BRAM, at factorfirm.com. Thanks again, Kurt, and thank you for spending this hour with us,
It's
and we'll
been my
see
pleasure.
you down the road. All right, thanks, everybody.
Thank you.